So is this one, obviously you're paying in each year. Is this liquidation or accumulation? You're accumulating, you're paying in. So that means it's the shorter formula. We'll finish punching it in here and we'll have an answer and see how we compare. I get, holy crap. Oh, I know what I did. I know what I did. What did I do wrong? Yep, this should be divided by 1, and that should be the power of 35. That would make a huge difference. Instead of $3,000 a month.
Just about to ask you, how did you come up with the 420?
Yeah, apparently I was sleeping. It's still over $1 million. 1,294,990.
50 cents.
49, yeah. That wouldn't be a bad retirement nest egg. Realistic for retirement? Well, let's look at a problem like that. What you really should have to live comfortably. Let's say you're going to retire at 67. How long do you expect to live? 68? 90? Okay, let's go to 90. So I'm putting in parentheses, that's 33 years. No, 23 years, sorry. 23 years. As you're drawing out, let's say you're going to earn 4%. You're going to start at, let's say you're going to start at what age? Anybody want to, what's that? 20? We're really planning ahead. And let's say you're going to earn 9% while paying in. How much would you have to put away each month, starting at 20, to make this happen? So we have to start, what we have here is we have the accumulation. We have liquidation. And for each of them, we have payment, time, and rate, and a lump sum, right? We're going to know the time and the rate for both of them, no matter what. We have to know the time and the rate. There's nothing else we can do. One of them, we know the lump sum or the payment. Right now, I haven't given you any of that. Starting at 67, living till 90. Retiring at 67, living till 90. How much do you think you would have to draw every month to live off of? Same way you're living before you retire. So what do you think your income is going to be right before you retire? Oh, what do you realistically expect it to be? I mean, yeah, I'd love to be living off $150,000 a year, but not unless I start selling kidneys. 40,000? In the United States, median retirement income right before retirement is about 52. Okay. Now, the 40,000 isn't a bad number because, let's face it, you don't have to drive to work, so you're going to save some gas money. Hopefully your mortgage is paid off or close to paid off. If not, a lot of people will actually sell their house and move into something smaller, a little bit cheaper anyway. Or a lot of times also you don't have to have all the work expenses, like if you have to have professional clothing and stuff like that, you don't need to spend as much on that. You usually do save at least a few $1,000s a year by not having to go to work every day. Now, if you have some expensive hobbies, if you're going to be out golfing every day when you retire, that's a different story. So anyway, let's figure $40,000 a year divided by 12. That's going to come out to be what? What, $3,333. Let's just put it at $3,500 a month. That'd actually be $42,000 a year. So what that's giving us is the payment we want in the liquidation phase. Now that we know the payment, we can find the lump sum. And this is how we decide where we're starting. We have to have either the payment or the lump sum for each of these to find the other one. We don't know the payment or the lump sum in the accumulation phase, so we can't do anything with that right now. But now that we know the payment in the liquidation phase, we can find the lump sum. So we're going to take that payment of $3,500 a month times 1, 2, 3. 1 plus, what's our rate in the liquidation phase? 0.04. Divided by 12. 23 years, what's 23 times 12? 276, look right. Minus 1, close, divided by, open, 0.04 divided by 12. Am I done here? Do I close and close? No, we're in the liquidation phase. We got that extra term. Times 1 plus 0.04 divided by 12, to the power of 276. Now we can close and close. So 3,500 times 1, 2, 3. 1 plus 0.04 divided by 12. Close, power, 276. Minus 1, close, divided by open. 0.04 divided by 12 times parentheses 1 plus 0.04 divided by 12, close, power, 276, close, and close. It's saying we would need 630,914.32. There are a lot of formulas out there. The bare minimum formula for retirement used to be 10 years salary at the rate that you were at right before retirement. So if you're making 45 or 50,000 right before retirement, that'd be about 500,000. That's the low end. Life expectancies have gone up since then, so now they usually do say 12 to 15 years worth of what you were making before retirement. Yeah, that's just your retirement life, not any like huge medical expenses or anything like that. Yes. Well, that's a conversation we're not going to get too deep into, but yes, they can liquidate your assets. You know, they can, if you don't have a spouse who's living in if you have a spouse who's living in the house, they can't do anything with the house, but if you don't, they can actually liquidate your house and other things. Otherwise, there are government programs to help pick that up. But there are... if
you have less than $2,000 in assets?
Yes, that's how they liquidate your assets before the government programs will kick in. And if you do have a spouse that's living in the house, they won't take your house, but they also will not... The government won't pay it. That builds up, and then when the spouse either passes or goes into long-term care, then they'll liquidate the assets to pay that bill back. You know, I'm not sure. You have a living one. Yeah, you transfer everything and do life estate on your property so that you don't technically own it, but they can't. You live there. It's yours until you die, but it's not technically yours. So now that we know we're going to need that much, Let's do the accumulation phase. $630,914.32 is what we're going to need. Divided by 1, 2, 3. 1 plus, we said 9% will accumulating. 0.09 divided by 12. To the power of, from 20 to 67 is 47 years. What's 12 times 47? Is it 564? 564 minus 1, closed, divided by open, 0.09 divided by 12. Now we do not have the extra term here. Sorry. So let's figure out what that has to be. I'm just going to leave that in there, even though there might be a slight round off. 1, 2, 3. 1 plus 0.09 divided by 12. The power of 564 minus 1, closed, divided by open. 0.09 divided by 12, close and close. Think you can afford that? $71.01 a month. But that's starting at 20 and paying till you're 67. Yes. And also the other thing it doesn't take into account is Social Security. The reason I put 67 for retirement age is that's when you can start drawing Social Security. If you're drawing out $1,500 a month in Social Security, well, now you only need $2,000 a month out of your own savings instead of $3,500. So that makes a big difference. My retirement plan is a massive coronary at about 70 years of age. Yeah. I'm not going to get into whether Social Security is a good thing or a bad thing, but I know I've done the calculations on what I've paid in. I've paid in pretty close to the max or at the max for Social Security for several years. Right now, if I kept paying in at the rate I am until I can retire, I cannot draw full Social Security until 60, almost 68 years old, if you go by the formula. Well, because of yeah, and it's also, I mean, my age. The way they've passed it is if you're under a certain age, it's 67 plus 1 month for every year you were born after a certain year up to whatever. And so if I keep paying in at the current rate up until I retire, and if I were to draw out the maximum, and I've adjusted that maximum for like a 1.5% cost of living increase every year, if I drew out that maximum at a modest 4 or 5% interest, I would have to live to 109 just to draw back what I've paid in. So I will never draw back what I've paid in. Yeah, I would be much better off if they eliminated Social Security and I took the money that I would pay in Social Security taxes and invested it myself. Even if I lost everything I've paid in already at this point in life and just started now, I would still be able to draw way more, I was assuming that it's from 68, I lived to about 88, so 20 years. I would be almost double if I just took that money and invested it myself, depending on what rate of interest I get. Yeah, and all it would be is you have to prove, just like they were saying that you couldn't force people to prove that they had invested, because they're saying you'd be required to put that money away for yourself, and you have to prove it. But they do, you have to prove you have health insurance now or you get penalized for it. So they could do the same thing. You either prove you've done the retirement insurance or retirement investment, or we're going to take it out of your income taxes and put it away for you. Yeah, it's, oh well, that's as far as we're going to go on that discussion. Yeah. I mean, I could go through the calculations, but there's a whole cost of living adjustment and stuff that gets, all it is really a compound interest calculation, but we're not going to get into it. There's a political argument there that I'll get wound up if I get talking about it. You can probably tell already what side of it I fall on. What's that? Well, you've already made sure that's going to happen. You already insulted me earlier. So. Yeah, let's not say you. Let's do. Kim is 31. Plans to retire at 62. Kim's gonna take the early retirement. Can invest Kim can be a boy or a girl. Kim can invest $250 per month at 12%. Kim hopes to live until, let's go, 88. How much will Kim be able to draw to, let's put all the words in there. How much will Kim be able to draw each month? What's that? Did I spell each wrong again? Oh, there. Helps to put all the letters in the words too. Month at 5%. I'm gonna have you give that one a shot. Let's take a peek and see how it's going. Now, obviously, for both, you know the time and the rate. That's a given. You either have the ages so you can figure out the time, or you have the years, and you have to know the percentage rate. That has to be given. The things we're looking for are the monthly payment or regular payment and the lump sum. Do we know either of those for the liquidation phase? No, we don't know how much that Kim's going to take out every month, and we don't know how much Kim is starting with. So we don't know either of those. So that means we're going to have to find the lump sum from the accumulation phase. The lump sum here is that the end of the accumulation phase is going to equal the lump sum at the beginning of the liquidation phase. So generally what it is we're given is we're going to give the regular payment for one of the two phases. And what we're given here, the $250 each month, is the payment during the accumulation phase. So how many years is Kim paying in? Starting at 31, going until 62, so it's 31 years. What percent? 12%. So $250 times 1, 2, 3. 1 plus 0.12 divided by 12. Close 31 years is 372. Is that right? Minus 1. Close divided by open 0.12 divided by 12. Close and close. So this is our accumulation phase. Let's find that lump sum. Anybody care to share theirs? No. Way to be brave. I'm proud of you. $987,723.89. 723. Anybody else come up with that? Anybody want me to give you time to try that again and see if you can come up with that number quick? Yeah? Okay, I'm going to pause for a minute. You get to work this time? Okay. So now then, that is the lump sum. That's the lump sum we ended the accumulation phase with. That's the lump sum we're going to start the liquidation phase with. So we do that divided by, in the liquidation phase, it is 5%. And how many years? From 62 to 88 is 26 years. So this is 1 plus 0.05 divided by 12, close. 26 years is 312 months, minus 1, close, divided by, open. 0.05 divided by 12. Now we are liquidating, so we have the extra term. $56.6305. So Kim's $250 a month for that 31 years while Kim is saving turns out to be over $5,600 a month in those 26 years that Kim is retired. Any questions? Anybody come close to that on their own? Got it? Cool. Pat inherits $40,000 at age 28. Pat invests it at 10%. At age 67, Pat retires and starts drawing it out. If, I'm going to really use some shorthand here, if at 5% interest and Pat lives to 91, how much can Pat draw each month? I'm going to give you guys a minute to break that one down. So this one, we're given the amount in the accumulation phase, but it's a little bit different because the amount we're given is not a monthly payment. So how are we going to start this one out? Well, we're given a lump sum to start with. So we're going to start out with the $40,000 in the beginning. Since we have a lump sum to begin the accumulation phase, and we're going to end the accumulation phase with a lump sum, is this an annuity calculation? No, this is a simple, not a simple, it's a compound interest question. So all we have to do is compound the interest. So 1 plus, what's the rate? 10%. Now I did not specify compounding in that beginning. Did you guys assume monthly? Yeah? Because we're making monthly payments or drawing out monthly in the end, so it's compounding monthly in the end, I would assume monthly compounding in the beginning since I didn't say anything. How many periods? 28 to 67 is 39 years, which is 468. And that's it. That's all that formula is for compound interest. So 40,000 times 1 plus 0.1 divided by 12 to the power of 468. So that is 1,944,420. And 31 cents. Can't forget the 31 cents. So that $40,000 investment at age 28 is almost a $2 million retirement. So now we're going to take that divided by what's going to go in here. What percent? 5%. Divided by 12. Now he's going to live from 67 to 91. That is 24 years. 24 times 12 is 288 months. Minus 1. Close. Divide by open. 0.05 divided by 12 times, parentheses, 1 plus 0.05 divided by 12. Close. 288. Close and close. So that amount divided by 1, 2, 3, 1 plus 0.05 divided by 12, power of 468. Is that? Oh, 288. You are correct. I looked at the wrong spot. Thank you. 288. That would have been bad. Minus 1, mainly because I really don't feel like typing this thing in again. Divided by 0.05 divided by 12 times open 1 plus 0.05 divided by 12. Close, power 288. Close and close. Holy crap. 11,606.20. How many of you think you can live off $11,000 a month in retirement? Unless inflation really goes out of whack. Yeah. I'd be living somewhere I'd probably be living in a couple of different places on $11,000 a month. The whole snowbird thing would probably take on a whole new meaning for me. Yeah.
I don't know if you can answer it, but why, like the second 0.05 divided by 12, why is that the only one where it's all the
Okay. What that is doing is this one here is 1 plus because it's 100 plus that. Because we're doing an increase. And this power is saying, okay, to that power. We're subtracting out the 1 just to get the interest. So that is actually figuring, this is actually figuring the effective rate. No, that will not work. Then this one here is taking it, well, like up in this formula. This second one here is then inflating that up for the number of periods. It's hard to explain it. I mean, I'd have to break down the whole formula piece by piece for you to really explain it.
That's alright.
What it's saying is if you take the period, that's the interest per period. So what this is doing is this is figuring out the interest for the whole thing divided by the interest per period will give you the lump sum then. You're converting the interest back into a total amount. What do you guys think? One more for you. You buy a house at, what do you guys want to pay for a house? What do you guys realistically think you're going to pay for a house? 100,000? I paid 80 for mine, but I had to replumb it because it was a foreclosure that froze up.
Yeah, there are houses.
120 is not a bad price around here. I did the research. The average 3-bedroom, 2-bathroom home in this area actually sells for about 112,000. Yeah. I did that calculation a couple years ago because I was looking at jobs in like Washington and then North Carolina. And like Washington, the average in the area I was looking, it was in Oak Harbor on Whigby Island up by Vancouver. The average 3-bedroom, 2-bath house was over 420,000. So we stayed here. So you're gonna buy a house at 120,000. Finance for 30 years. I want to know what's the difference between 3% and 5% in total cost. So in other words, we talked about this a little bit before when we did proportions. Your credit score does not necessarily determine whether you get the loan or not. There's a minimum threshold. If you got a credit score below 500, you're not getting a loan. Because below 500 means you probably defaulted on other debts in the past and they're not going to touch it. But usually it's about 625 or 650 if you're depending on the institution. If you're above that level, you're going to get the loan if you have the right debt to income ratio. Debt to income means your monthly debt payments compared to your monthly income, total income before taxes. Usually it's a 1 to 3. You got to be below a 1 to 3. So if you make $3,600 a month, you have to have less than $1,200 in debt payments, including the new loan that you're applying for. What the credit score comes in is what your interest rate's going to be. If you have that credit score sitting around that 625 and you just barely qualified for the loan, you might pay as high as 5%. I've seen them 4.9. I think I saw one at 5.9 that someone had got, but they had a really poor credit score. If you have a good credit score, up around that 710 to 720, you can get it down to 3%. Now, if you have an excellent credit score, I've seen some of these go as low as 2.375 in the last year. You're talking about above a 750 plus credit score. But anyway, I want you to figure out what is the monthly payment at 3%, then what is the monthly payment if you have 5%. Then we're going to compare. So let's start out doing the monthly payment right now at 3%. I'm going to give you a couple minutes to figure that out. Then that's after the down payment. We're going to finance 120,000. Good point. So we're looking at like $145,000, $150,000, probably $150,000 house before down payment. So for this one, 120,000 divided by, we have through parentheses 1 plus 0.03 divided by 12 to the power of 360 and minus 1 divided by, after here, 0.03 divided by 12. Is that it, or do we have the extra term? Extra term. What'd you get for payment? Be brave. We won't judge. I've screwed it. Perfect. 505.92. Now we're going to do the exact same calculation, but at 5%. What'd you get? $644.19. That 2% interest is going to cost you $140 a month almost. So now let's do this. Total cost at 3% is $505.92. 360. $182, $131.20. So you pay about half again as much. At 5%, $644.19 times 360. $231,908. 40 cents. Bless you. Again, almost an extra $50,000 for your house if your interest gets bumped up because of poor credit. It is. Back when I bought my first house, rates were, this was in 97 when I bought my first house. Rates were actually pretty high. I mean, car loans were 9.4, 9.5%. Some of them were up to 11 or 12%. Mortgages were around that 7.5 or 8%. I paid 7.65%, and $39,000 after a down payment. It was $37,000 because at that time, even 5% down was good enough. Yeah, $37,000 loan. The estimated payment, total payment, was like $91,000 or $92,000. It was about 2.5 times what the loan was, what the original amount was. So that's at 7.65%. Let's say you are offered a 15-year loan at 2.4%. find payment and total cost. So 15 years is 180 payments. Anybody get a number for the payment that they want to share? $794.51. So compare that. $644 is if you had 5% for 30 years. $794 is $150 more than that. And you're done in 15 years. How many of you got the $794? 2 of you? So then our total is 180 payments times $794.51. I'm just going to use the number on my calculator here, so I'm going to be a little off. But $143.11. $143,011.88 or 87 cents. I probably rounded a little off there. So you're saving yourself $40,000 in interest, even over the lower rate. Saving yourself almost $90,000 over the higher rate. Now this rate's gone up in the last month. I think 2.4% is unattainable. I just refinanced at 2.625, and if I'd had a better credit score, it would have been 2.375. So it's out there. That's only on a 15-year. On a 30-year, I think the lowest was 2.875. But still, it makes a big difference. Anybody have any questions? Okay, next week is your test. Topics you need to know. Simple interest. I equals PRT. You may, obviously the one we're used to is finding I, but you may be asked to find the principal or the rate or the time. So missing pieces of that formula. You'll need to know the difference between exact and ordinary interest. That, of course, is for simple interest-bearing notes. Remember, if you hear the word simple interest, it means simple interest-bearing. If we're not told, do we assume exact or ordinary? Ordinary. And ordinary is which one? Out of 360. Exact is out of 365. Remember, we count the days the same way either way. When we count the number for the numerator, that's always going to be a 365-day year. The only thing that changes is what we put in the denominator. Then, of course, there is a simple discount note. So for a simple discount note, you have the discount, you have the proceeds. Remember, the amount of the note is what you pay back, not what you get. So you figure out the interest and you subtract that from the amount you're going to pay back to figure out how much you're going to get. In a simple discount note, there is an effective rate you will have to be able to find. Now, dealing with just simple interest, there are two processes you have to be able to do that are somewhat complex. The first one is the U.S. rule, and that is for partial payments on a note. This is the one where the loan started out day 0, day 32, they paid $2,000, day 65, paid another $3,000, day 90, 120, whatever, was maturity. You had to find the balance due at maturity, the total interest. Of course, the balance due, the balance after each payment, all of those. Does that look familiar? Any questions on the U.S. rule? Anybody desperate for an example of that? Okay. This is simple interest. Bearing. So you're starting out with a principal and adding interest to it. Now, the other process dealing with simple interest that's complex, I think it's one of the most complex processes in the course, is discounting a note. Remember, that starts out with an interest-bearing note. So that interest-bearing note has a principal. You're going to be adding interest to it to get to a maturity value. But somewhere in the middle of this, you discount it to a bank. And that is a simple discount note. And the value you're discounting is the maturity value. The period is the number of days left. The discount period is the number of days left from the time you discount it to when it matures. And you'll find the proceeds. Any questions on that process? Anybody desperate to see an example of that one? I shouldn't say desperate. Anybody want to see an example of that one? You do? Okay. So let's say here, I'm going to have you guys somebody pull out their date chart in their book for me if they would. On May 5th, Tim extends a $3,000 note to Pat at 6% for 90 days. On June 12th, Tim discounts the note to a bank at 8%. We're going to find Tim's proceeds. So let's start out with the dates. May 5th is what day? 125. June 12th? 163? Okay. So first step is always maturity value of the original note. So that maturity value is going to be the interest. So it's going to be $3,000 times, its rate was 0.06, 90 days, so 90 over 360. It's $45 of interest. So the maturity value is the 45 plus the 3,000. So it's $3,045 maturity value. Step 2 is to find the discount period. Now, we started on day 125, went to day 163. 163 minus 125 is 38 days. Is that our discount period? No, that's the days that have gone by. The discount period is the days left. So it's a 90-day note minus 38. That is 52 days left. That is the discount period. Step 3 is the bank's discount. The bank's discount is off of the $3,045, that maturity value, at the 8% discount rate for 52 days. $35.19. That's the bank's discount. So final step, Tim's proceeds. Is it Tim? Yeah, it's Tim. Which is the $3,045. That was the maturity value of the original note minus the bank discount. That's $3,009.81 is what Tim actually gets. Does that make sense? That's the tough, like I said, I think that's one of the toughest concepts in the course. So that's all of our simple interest. Next we had compound interest. Compound interest, we either had the present value going to the future value, in which case we multiplied, or we had the future value going back to the present value, in which case we divided, and you'd either use the table or you could just use the term 1 plus r over n to the power of n times t. Again, if you know the present value and you're looking for the future value, you're multiplying. If you know the future value and you're looking for the present value, you are dividing. Or present value is now, future value is later. The trickiest part with compound interest is effective rate. When we find the effective rate, there are two possibilities. The actual time is less than 1 year. And we use the actual time. If the actual time is more than 1 year, we use 1 year. Any questions on the compound interest? Anybody want to see an effective rate calculation? Yeah, okay. In fact, let's do two of them. Let's find the effective rate of $2,800 at 8% compounded monthly for 9 months. Step 1, find the future value. .08 divided by what? It's monthly, so it's going to be 12. To the power of, how many months are in this one? 9. It is less than a year, so we use the actual time. So 2972.55. That's future value. The second part is to find the interest, which is going to be subtracting the principal. This is $172.55 in interest. Step 3 is the effective rate. We know the formula I equals PRT. 172.55 is the interest. The principal is $2,800. The rate is what we're looking for, and our time is 9/12 of a year. We've gone for 9 months. So our first step is to combine the 2,800 and 9/12, which is 2,100. Dividing by 2,100. .082166 is our rate. Remove the decimal point. 8.21667%. Now we have to know whether we're asked around to the 10th of a percent or the 100th. If it's the 100th, this is 8.22%. Questions?
Now, how did you get the 2,100?
2,800 times 9/12. Times 9 divided by 12. Other questions? Let's say you invest $5,200 at 7% compounded quarterly for 8 years. Find the effective rate. You guys tell me what to do. What's step 1? Ambitious group tonight. Future value. What are we going to use here? $200 times 1 plus 0.07 divided by 4, because it's quarterly. To the power of, do we do 4 times 8 is 32? No. What do we use? 4. Since it's more than a year, we go for 1 year. Don't forget that. That's what I will catch most people on if they screw up the effective rate calculation. So 5573.67. The second step, of course, is to find the interest. So minus the 5,200 That's going to be $373.67. So then our effective rate will be the 373.67 equals 5,200 times R times 1, because we're going for one whole year. So the 5,200 times 1 is just 5,200, so I'm not going to bother to multiply that out. We're just going to divide by 5,200. .07185,860. Moving the decimal point, 7.1860%. Again, if you're rounded to the hundredth, that'd be 7.19%. And then, of course, need to know all of our annuity stuff. For the accumulation phase, need to know ordinary annuity, which is everything we did tonight where you're paying in was ordinary annuity. And you need to know annuity due. Annuity due is just that extra factor. No power on that. Just 1 plus R divided by N. It's the interest for one period is all you're doing, is adding. And then, of course, liquidation phase. Liquidation phase, or something called a sinking fund. The term sinking fund just means a loan. So you're paying back a loan. It's the same formula. So that's it. That's all you need to know. The biggest thing is, remember, look for keywords on this test. If it is a lump sum to a lump sum, as we discussed, that's just compound interest. Simple interest will have the word simple in there at some point. If it's payments going into a lump sum or lump sum going to payments, it's annuity. That's the biggest thing people will mess up on this one, is difference between them. There is a quiz due tomorrow. Yeah, and you do have a new homework due for next week. If you have corrections on test 2 to do yet, those need to be to me next week. Next week's test, I will try to grade them as you're finishing them up. So I'm hoping to have them graded by Friday morning. For some of you, if you get it done, if you want to stick around for maybe 10 minutes after you're done with the test, I hopefully should have it graded before you leave. You can take it with you next week, Thursday night, so you have it to take home and do corrections. I won't submit grades for this class until noon on Wednesday the 21st. So you have till noon on Wednesday the 21st to get that to me if you want to do corrections.